All right. Hello, everyone. Thank you for joining us here tonight or your morning. And we're going to start in a few more minutes so that less people join in to the broadcast. So let's have about 2 or 3 more minutes. Meanwhile, if you want to, you can go to our site to start setting up your questions. If you want to have them later, the slide, you can see the site here. And we're going to start in about 2 or 3 minutes. All right, perfect. So, hope you're all doing well. Our plan for today is to talk a lot about middlewares and some interesting things that you can do with them in Redux. And most of the time, we'll be doing live coding, and everything written here will be available as a GitHub repository after we finish the podcast. And the video itself will also be available later if you want to review anything that we've done or tried here. All right, so a few words about myself. My name is Boris Dinkiewicz, and I'm one of the co-founders of Fantan Tech. I've been teaching React and Redux for the past React itself about 3 years, and Redux about 1.5 years or so. I'm doing a lot of conferences and workshops all around Redux. And as you might have guessed, really big fanboy of Redux and what Redux can do. I'm also a co-author of a complete Redux book, which is available for free with this link. And I'll have the link up also later on. And I work for a company called Fantan Tech. We specialize in consulting, training, and projects in the world of JavaScript, mainly in React and Redux. And if later on you have any questions or want help with anything, we'll be happy to help. You can find all the contact details on the site. So one thing that's important about this webinar is it's an advanced one. So I'm going to presume that you already know React pretty good, and you understand all the basic concept of Redux, and we're taking it from there to the more advanced level. And if you have any questions, there's a site, it's called Slido. And inside, just put Redux as an event code. You'll be able to post your questions there and upvote other questions that you like. And I'll try to stop from time to time and answer any questions you might have about the code or the things I'm trying to teach you. All right, so without any more delay, let's go to the code and see what we're going to be working on. All right. So the base for our talk today is going to be a very simple project. The idea here is we have some kind of small library with a list of books and a list of offers for each book. Currently, the library supports basic server communications, so we can get a list of offers from a remote server and a list of books from a remote server as well. And we have this nice little feature on the bottom that allows us to change colors or themes for the project. Now, one of the more important things that I always look at when I start with a new project with Redux is at the store itself. So here the store is exported to the console, and you can just go and get the state and take a look at what's happening inside. So our state is pretty simple. We have 2 keys for offers and books, and out of the offers, you can see, is a simple array containing an ID and a name. The books are a bit more complicated. Again, it's an array. For each one, we have an ID, the title of a book, and a nested object containing the offer. Another key that you might notice here is the UI. And currently, it only holds the theme, but we'll see how we can use it for more advanced things later on. Now, the structure of the project itself is pretty simple. We have the Redux initialized in a store, and our whole application is 2 panels, as you can see from here. The top panel of the offers and the bottom panel of books. Each one is completely self-sufficient and is a connected component that fetches all the information directly for the state. And that's it, nothing exciting about here. And let's talk about middlewares. So I personally think middlewares are one of the more complicated and useful things you can do in Redux. Unfortunately, they have kind of a bad rap. And a lot of people never use middlewares for anything and rely on workarounds and libraries to do the work for them. What I hope I'll show you today is that middlewares are actually pretty strong and simple to use if you really understand what's happening. So what is the basic idea of a middleware? This is a regular flow in Redux. We send an action via the dispatch to the store. The store calls the reducer with the action and the current state. The reducer calculates the new state, and that's the new state for the store. The idea of middlewares is just to add a few listeners on the way. So now when we send an action to the store, it's not getting passed directly to the reducer, but rather passed through a chain of middlewares, each chain of all the actions happening in our stack. In this way, we can do some pretty cool stuff on the way. So let's create our first middleware and see how we can do it. I'm going to go to my middleware directory. And as you can see, I already have two little middlewares here. We're going to talk about them a little bit later. A very basic middleware that usually exists in most projects, and that's the log middleware. Now, I think the most scary thing about middlewares is the way you define them, because it looks something like this. Function API middleware that receives an object that contains get state and dispatch, which in turn returns another function that receives next, which itself is a function, and then returns another function which receives the action being passed. And only here we do the action without code. Now this thing looks a bit scary, but if we move it to the ES6 arrow function syntax, it looks much better. So const API log middleware, get state, dispatch, get a function that receives next, and get a function that receives action, and that's it. Much cleaner and easier to understand. Let's remove everything here. And since I'm using WebStorm, I already have a few live templates ready. So when I'm trying to code new middlewares, I can use a live template for that, middleware, and everything gets created immediately. So nothing really scary about it. So let's try to do that. So we said the idea of middleware is every action being passed to the store gets passed through all the middlewares on the way. And what I want to do from our log middleware is to just output it so we can see what actions are being sent. Right? Because now when I click on the switch theme, I know it's working, but there is no real way to see what's happening. So of course we can use other tools like the Redux developer tools for Chrome, but the middleware might be a bit easier in most cases. So let's try doing that. Console log will just print the action being sent. Let's print the action type and the whole action itself as well. All right, let's run this. And now when I click switch theme, well, nothing really happens. And the reason nothing happens because we created a file log middleware, but we didn't really connect it to Redux. Now the way we connect things to Redux is we go to the place where we create the store, and we use a new function available for us from Redux named apply middleware. So here the structure is a bit more complicated because we're using Redux developer tools, but in theory what you would see is something like this: const store, create store, the reducer we're going to use, and then apply middleware, and just a list of middlewares. Middleware, middle 1, middle 2, middle 3, etc. In our case, we already have apply middleware set up here, so all we have to do is add our log middleware. Let's add it here, and of course import it. Import log from middleware log. So let's see what happens now. I'm going to click on the bottom and switch theme, and as you can see now we get the log message, action time being sent. But something broke. The color is no longer changing. As you can see, we're stuck with the red color. So the middleware is getting called, but for some reason, the reducer is not getting called. And the reason being, in the middleware world, you have to explicitly pass the action on to the next middleware in line. And for that, we have the next parameter here. So all we have to do is call next and pass on the action. Let's see what happens now, and hopefully the middleware is working exactly as intended. So a common question is, why do we have this weird structure of next action? And the reason is pretty cool, because what we can do now, we can get the state before the call to next, and get the state after the call to next. And let's see what happens. So I click switch theme, and as you can see, the call before, we have the theme as 0 in the UI, and the call after, we have the theme as 1. It means we can decide when we want to run our code, before the middleware passes the action down to the reducer or after. A bit more power, and can be really useful in many use cases. So let's scale back to our simple middleware. Everything is working great now. And I want to show you something a bit more complicated. So this middleware is some sort of a catch-all, right? Any action being sent is caught by the middleware, and something is performed. But we can use middlewares for more targeted things. For example, let's look again at this switch theme button. So in our case, switching a theme is just changing a number, which changes the color. But maybe in a bigger application, clicking on switch theme also calls a call to a server, some kind of updates, and maybe some more complicated work. And we don't want the user to clicking switch theme too fast, and only want to limit it to, let's say, switching a theme only once every second. So let's take a look at our React code. So the switch theme code is located inside the footer. You can see we have a theme manager here in the footer, and in the theme manager we have a button with a simple on-click event handler, which calls switch theme, which is an action creator. Now let's say I wanted to limit the number of clicks here. And one option will maybe to use a library _dash or underscore and create some custom code here around the on-click event, and which could work. But then any place when you like to use the idea of throttling, we'll have to copy the code, edit again, test it again, and make sure it's working correctly. But now that we have the power of middlewares, we can try to do something a bit more interesting. So let's go to our action creator, switch theme. And as you can see, it's a very basic action creator. It returns back a simple object containing the type, which is the switch theme. What we really wanted to do is to make sure that this action is not passed to the reducer more than once every second. Imagine if you could just go here and say, you know what, I want to throttle this event by, let's say, 1,000 milliseconds. So let's try this now. Throttling on, I call switch. As you can see, now we get the type and the throttle here, but, well, it's not working. Which makes sense, because no one knows what throttling is. But I can tell you a secret. I went on and created a very small middleware already, and call it throttle. This is a whole middleware. What the throttle middleware does is something a bit more complicated. So it looks inside the action to check if there is a field called meta. And if you're familiar with FSA, flag standard actions, that's a place where you can put special data about your action. And then inside the meta, we check if there is a key named throttle. And if it exists, then we throttle the whole action. So let's try doing that and go back to my UI. And instead of having the throttle here, we'll add a key named meta, and inside of it, put the throttling on. Let's try this now. Everything is still working, but now, even when I click multiple times, the theme is changing only once every second. So the nice thing about the user middlewares here is if you look at the action creator, we didn't create any complicated code. Right? There's no synchronous code here. There's no timeouts, no intervals. Everything is just magically working for us. So all we need to do is go to the throttle middleware, add all the required tests, and that should be enough to have the middleware working for any other case. We can do the same for pretty much any action we have, just adding meta and throttle. So adding the throttle is only the beginning. Of course, with time, we can create more complicated middlewares. Let's say our project manager comes in, and he wants to know every time one of our users changes a theme, because he wonders if that feature is really needed. And what we'd like to do is add some kind of Google Analytics, for example, event. So one way we can do that is go back to our theme manager, like to this area, and instead of calling switch theme directly, create a function that both dispatches an event and also logs an event with Google Analytics, which is great. But again, we can use middlewares here. How about we just go inside our meta and add a new key, let's say Analytics switch theme. What we can go and do now is create a new middleware that catches all the actions that have the meta key and the analytics key inside of it, and then automatically send an event to Google Analytics. The nice thing, again, everything is completely declarative. There's no complicated code here. And if for some reason tomorrow you want to switch from Google Analytics to any other provider, the only change that needs to be done is inside the analytics middleware. Again, only one place. Any questions? Again, I remind you, you can go to Slido and post them here, and I'll try to answer them. Okay, so we've done the easiest parts of middleware perhaps. So we have one middleware that catches all the actions. We have another middleware that knows how to catch only part of the actions depending on the, let's say, the flag or a special parameter. And let's talk about the third type of middlewares. And this one, for this one, we'll be looking at our network communication. So what really happens when I click the reload button here on top? So you can see it on the right side. We have a GET request to the server, and then an action, set offers, whose payload contains the list of offers we get from the server. Now, how does this work? Let's find the code behind it. Let's go to the offers component, and what we have inside here is the list of offers and a panel, which is the top bar, right? And inside the panel, we have the reload button. Let's take a look. And here's the reload button, calling the callback we received. So what we have here is every time someone clicks on fetch, the fetch offers action creator gets called. Here, it's defined inside the action offers. Okay, I see we have a few questions. I'm going to stop for a second and answer them. So the first one was, Redux might be a bit tiring. Would you recommend Redux for pure state manager and something like Angular services to manage basic UI interactions? I know that React might feel a little bit tiring, mainly because every time you want to add an action, there's quite a few different places where you have to add it. But it brings a lot of power with it. So the main power of Redux, in my opinion, is for really large projects. As your project grows, Redux allows you to really easily divide the project between different teams and have almost no interaction between the teams, which allows much easier testing and deployment. If you're writing a really small project, Redux might be a bit of an overkill, and then something like Mobix might be more better done. I'm not sure how Angular services might help with managing basic UI interactions, because Angular services in the core are just code written in one file or compiled into one model. And if you want to have basic UI interaction inside of React, well, you can just use React components and set state. You don't really need another library. Another question was why I needed the meta object in the action creator, which is a great question. So let's take a look at my back-against switch theme in its original view. So let's say we added the throttle here, and then we added analytics here, and switch theme, and then later added more stuff, and then maybe even added data we want to send to the reducer. Right? So payload, data, data. Now, looking at this action is really hard to understand what is what, right? So the type we know is required, the data is something that's being sent to the reducer, and these fields, well, I'm guessing they're being passed to a middleware. But it's really hard to tell because there's a lot of noise. So there's one idea behind writing action creators, and it's a kind of a standard created. It's called FSA. And the idea is just to divide the action into more manageable chunks. So the type is required. Then we have the payload, where we put everything we need for the reducer. For example, the data is also part of the data sent to the reducer. And the meta tag that holds all the information that is not directly sent to the reducer, but mainly has to do with description of the action itself. So we want to throttle the action. Our reducer doesn't care if the action is being sent every second or every 5 seconds. It only cares about the data itself. And again, analytics is something that's not really for the reducer. And slowly our meta can grow. For example, might have something like no debug true, because it's a message that gets sent along, and we don't really want to see it in the debug log. And that's the main reason about dividing your action into multiple parts. And FSA is kind of a startup, so there's a lot of open source libraries that already build your action creators according to FSA, and then you can use multiple libraries in the same project, and they all work together in harmony. So I hope that answers the question for why to use meta. Another question I have, I feel tired as a developer, you're writing same scenarios every time fetch, edit, tag. Do you have good tips? Well, I hope as we progress here, you'll see we can save quite a lot of time with middlewares and figure out how we can make a project better. Of course, making generic projects is everyone's dream. So you write a little bit of code and it works everywhere. It can be done with Redux, but everything, of course, depends on the project. So I'm going to jump back to our fetching example, and then we'll do a bit more questions if you have any. Right. So we stop somewhere here, right? Clicking the reload button sends an action, does the server access, and then send an action. The way it works is we go to our offers. We have the fetch offers action creator. Let's take a look at this action creator. And you might be familiar with this. This is using the Redux func middleware. So what Redux func allows us to do is something a bit unusual in the world of React. Right? Something like this: export const action creator, get some params, and then we return an object with a type and, let's say, payload. With Redux func, we can do something a bit strange. Instead of returning an object, we can return a function that receives that state and dispatch. And that function can do anything it wants, theoretically doing a dispatch sometime later. So that is the normal way you'll probably see server communication done if you're doing online tutorials. And it works, but it has a few problems. So let's take a look at the fetch offers action creator. What it does, it receives a dispatch, and then it uses a new fetch API to contact the server at API offers, receive a response, and once data is received, we dispatch a new action that sets the address. Basically, the set offers is the one that reaches the reducer and changes the state. If I take a look at the books action creator, I might notice something very similar. So I'm going to pass them here together. Fetch offers and fetch books at the same time. As you can see, the code is almost exactly the same. The only difference is the API we're trying to access and what action we call when the API is successful. So you might notice there are a few problems with this code. First of all, there's no arrow hanging here. And there are other missing things. We don't set any headers. Maybe we have authentication on and we want to send some headers. And one way to solve it is to create a generic layer on top of this fetching API that accepts different parameters and then does the work. And that thing kind of works, but it shows us another problem. The fetch offers action creator is asynchronous, right? It returns a function that gets called and then does some asynchronous work here. So testing this function can be quite complicated. if you compare it to testing a regular action creator, which takes about 1 line of code to test, since it's always a set object, this is much more prone to errors and mistakes. So maybe we can do something smarter. Maybe we can take all the parameters, all the difference between 2 different action creators, and somehow encode them and let someone else do the complicated work. For example, let's try to do it. Export const fetch authors. Let's call this the old fetch authors. And this is going to be a new one. And what I want to do here is immediately return an object, a regular action creator. So we have to have a type, right? And what kind of type we want to have? And so it's a big question here. So we want to have a type that kind of gets caught by a generic layer, hint, hint, middleware, which will perform the fetching for us. So let's create a new type. We call it API. That's going to be the type for all our API calls in our Redux stack. Inside the payload, we're going to put all the information the middleware needs to be able to communicate with the server. So we said one of the things it needs to know is the URL one access. In the case of fetch offer, this is the URL one access. And another thing it needs to know is what action creator to call if the fetch was successful. So let's say success, when it's success, call set offers. So all the data that we have here is now encoded in a regular JavaScript object. Easy to understand, easy to test. Let's give it a try. Let's see what happens now when I click. Export const fetch offers. Now when I click the reload button here, that we see on the right, an action is going out, the type is API, and the payload contains all the information we need to perform a fetch. Of course, nothing is happening now because there's no middleware listening to this API call. So let's do that. I'm going to go to my middleware directory, middleware. I'm going to call it API. Again, I'm using live templates from WebStorm, middleware, and I got the middleware ready. So how do we know if the action being passed from the stack is targeted to the API middleware? Well, we said it's pretty easy because all actions sent to the API middleware have the same type, API. So it's going to be really easy to know if the action type is equal to API, then do something. Or if you want to make the code a bit clearer, if it's not, then just return and pass the action to the next middleware in line. Import, let's import the actions, import those actions from action types. Perfect. Log, let's do server work. And let's see if it's working now. So I'm going to click the offers, and the action is going out, but we don't see the message. And again, the reason behind this is we didn't register our new middleware with the store. So let's go to the store and add it to the list of middlewares, API. Try this again. And now when I click the reload button, as you can see, the action is going out, and the middleware is catching the button and is ready to do the server communication. So how do we connect to the server? Well, we already have the code, right? It's here in the offers. Let's steal it for a moment. Or you know what? I'm going to just write it from scratch, so it's easier for us. So first of all, we're going to call fetch, and we need to know which URL we're going to call. And the URL, as we've seen, is already encoded inside the action. So let's get that from there. We want to get the URL and the success method from action payload. Simple EL6 destruction. So let's call the URL. It returns a promise, which returns a streaming response. Response. Let's convert it to JSON, which also returns a promise. And now we get the data. Console log data. Let's try and see if it works now. I'm going to call reload. And perfect. So we have the action going out, we have the middleware catching the action, we have a server communication going out, and the data is returned by the server, which is an array of offers. So the last thing will be, once we have the data, we want to notify Reducer that the data is received. And luckily, we have everything in place. The middleware has a dispatch function passed to it, so we can call dispatch. And the action we're going to pass is the same parameter passed inside the success, right? Action payload success has the action creator we want to call to pass the data to the reducer. So we'll just call success and pass it the new data we received. So let's see what happens now. I'm calling reload, and we can only see the data here. So the initial API action going out, the middleware is catching it, and it's doing the fetch, and then it's setting the set offers action creator, which has inside of its payload the list of data we want. And that data is added to by the reducer to the list of offers. Pretty simple. Let's try to do that exactly the same thing, but for the second API, which is the books. So let's take a look at the books. It has the same structure. We have a panel with a callback for fetch books. Let's take a look at fetch books. Again, it's a Redux func-based action creator that does the fetch immediately. So let's mark it as old and create a new one. Export const fetch books. And we're going to return a regular object. So the type is actions API, and the payload has all the information we need. So we said we need the URL, which is here. And we need the success callback, which is set books. Right. Let's try the new code. The offers is still working. And now, I'm going to clear the console. I'm going to click the reload on the books. And everything is working exactly the same way. API action is getting sent out. Now it has a different URL and different success. There is a call to the server, and an action set books being set with the payload containing the array of books wanted from the server. So as you can see, I'm going to remove the old code now. All our action creator is now plain JavaScript objects. They're super simple to test. Basically, there's no test you can do for fetch books because you call it with no parameters, and it always returns exactly the same thing. So the test is super simple, and all the complicated stuff is hidden away inside our middleware. So of course, this middleware is super simple. It's not the real middleware you're going to be using. And a real middleware might contain more things. And let's make a test, a kind of thought test about another API access. So what I've done here is an API access that fetches information. How about if we wanted to update something? Let's say, export const, we wanted to update a book, which means getting the ID of the book and a new name for the book. We're going to try to do the same structure as we've done before using the API middleware. So that means I'm returning a regular JavaScript object. The type, again, is actions API. And the payload is going to be a bit more complicated. So if we're using a RESTful API, our URL might look something like this. Might be API, books, and then the ID of the book we're trying to update. And let's say Node.js. The method here is also different. It's not get anymore. It might be update or create. Let's say update. And the data, the post data we're sending to the server, might contain just an object with different properties like name, new name. We can see we can use the same ideas to do updates, deletes, and anything we want with API in a completely declarative style, which is easy to test, easy to understand, and has a one nice feature, it's easy to debug. Because if you look at the log now, you can see that we asked for an API, we've seen all the parameters, and even if something goes wrong, we know what happened here. So if a get is suddenly has a problem, something here, we know the problem was in the action creator. So it's not a put, it's not update, it's a put. Yeah. And with time, our API middleware is going to grow. So here we already need to add support for method and for data. We might want to add things like timeout, because I want to have custom timeout, because updating a book might take a lot of time because we checking it against, I know, Amazon's book database to verify the duplications. And we might want to add, for example, custom error. So if there was a problem accessing this API, I want to have a custom error displayed or custom message. Again, it depends on the project, and there's quite a few API middlewares out there already implemented in open source. And I'll post a link later on to one of the implementations we use, but it's really easy to write. So a real-world API middleware might be maybe 3 times larger than this one. It's not that much of a code. Okay, so we have a bunch of questions. I'm going to stop for a second and try to answer a few of them. I want to delay user interactions once the fetch is done. Should I delay my store from updating, or do you see this as a pure UI React implementation? That's kind of a weird question, and I'll tell you why. I'm not sure why you would want to delay user interaction after the fetch is done, because then you already have the data. And so one thing, like a really proper disabling of future interaction will be disabling the buttons. So the user can see that he can click the buttons. But if you want to only have a perceived delay, maybe you can, in theory, have a middleware that catches all the actions being sent. And if a global flag of delay is set, then it just caches them and outputs them once the flag is off. So it's very similar to what we had here in Throttle. I can just create a list of all the actions pending and just continue adding to that. And once you flip the bit saying, that's it, you can send the interactions, all the actions are going to hit the reducers. But I have to say, I don't really understand the use case for this question. What helps you decide if a component should be connected directly to the Redux store, or if it should get errors and state via props? That's an excellent question and very hard to answer. You have to remember that connect, this thing at the bottom, is extremely efficient. So you should never think twice about using connect. Definitely not because of performance. If you think you need data from the store, just use connect. Only in very extreme cases, you might find that connect impacts performance. You'll be able to fix it on a case-by-case basis. And so if there's a question of should I add connect, just add it. The nice thing about connect is if I look at my app now, let's say the offers component, I have no idea how offers component works, right? It's just magical. Somehow it does everything, and I love Redux for that. I have components that automatically fetch everything they need. If I had to connect to the app and get the data for the offers myself, it would make the offers component less reusable and my app more complicated to use. So as a rule of thumb, I would personally just connect anything I want and only pass props when it's pretty obvious that you need to. I don't know, maybe let's say look at the books. So the list here receives a list of books. Since list is generic component, I wouldn't connect it to the books state. So it's something I would do in books and passes it props. And again, it's a bit of a black magic, of course, but don't be worried about using connect. Connect is amazingly performant and efficient. Okay, so now our question is, beside code modularization, what problem do we solve by refactoring the fetch method into the middleware layer? So it does a few things. One of the things is, of course, debugging. Imagine if you have a user in production and something happens with their code. Now, if we talk about projects written in Angular 1, there's no way to know what happens. So you might ask to get the dump of exception key got, but it will be really hard to decode what happened. In the world of React and Redux, we can do something pretty cool. So let's look for a second at our log middleware. I'm going to make a little magic here. Window actions. I'm going to create a new item window, and window actions push action. I'm going to click some buttons here. So this is the user on a production. He's playing around the app, and suddenly something breaks. We have a global exception. What we can do now is just look at the actions array, and we get a complete array of everything that ever happened on the front end. Right? We can take this information and create a bug, let's say, in our Jira, with all this, the initial state the user started in, all the actions that happened, and then locally as a developer, I can rerun all of them and get to exactly the same state in exactly the same way as the user who got the error. Now, if you're using Redux Func, you won't be seeing the API calls. What you'll be seeing here is suddenly set books, set offers, and maybe an error. With the API, you can know exactly that the server, the front end tried to communicate with the server, exactly what was sent, what was the idea of the communication, and then what happened as a result. So it's much easier for debugging as well. And I think the biggest thing, though, is still testing. Creating tests for a full API middleware may take you 1, 2, maybe 3 days, but once you're done, you know that it's complex asynchronous code is fully tested. If you try to test each one of your action creators that does any server communication, it's going to be taking you weeks. And you'll always be missing special edge cases. For example, if the error you received is access denied, what should you do? Maybe you should log the user out. If the access is not found, then maybe you need to do something a bit different. That means for every asynchronous action creator like this, you have to make many different tests and test it every time. And of course, looking at this code as a developer is much easier to understand and read than having a lot of ifs and fetches and thens and complicated flow. All right, so there's another question here, which is a bit more complex. Stacking a bunch of middlewares looks somewhat like an anti-pattern for managing side effects. What is an alternative? I'm not sure. That's a good question. Stacking a bunch of middlewares. I'm not sure if it's really an anti-pattern. So the only thing that's kind of painful in this is that the order here matters. So if I put the throttle before the log, we'll see the log events only throttle before the log. Did I disable something here? Let's see. Yes, I moved the throttle to a second. So now as I change the order, I can see the log actions are coming only once a second. But if I reorder them, the log middleware is getting called before the throttle. It's a bit of an annoying thing. So you have to be careful by the way you add middlewares. But I have to say, even in a large project, you won't be having hundreds of middlewares here. You might have maybe 10. So it's not that big of an issue. And since each middleware has something specific that it does, it shouldn't really collide one with another. So if we had the analytics middleware here, and maybe, I don't know, something else here, each one has a different role. One shouldn't affect the other, so they shouldn't really collide in any way. I still think the middlewares are the best approach for large applications because you can have discrete pieces of code handling closed missions, each one, that are not connected to each other. If anyone knows other cool patterns, I would love to hear. You can leave them in the comments as well. And the last question I'm going to answer is, how do you write tests for middleware? The same way you write tests for any other component. Like the middleware, in the end, let's take the log middleware as a simple one, this is just a function. So if you're using jest to make your tests, just test it as a function itself. If you want to have more complicated tests, there are a few libraries that allow you to bootstrap the middleware to a more, let's say, coherent state, connected to the store and everything. And then you can test it with a reducer and check that the reducer is getting called correctly and that actions are getting passed onwards. But at its base, this thing is just a function. So you can test it as a function. Let's continue. So we have a middleware running. Everything is nice and fine, but I want to add a bit of a more complicated feature. So what I would like to have is that when someone tries to reload the offers, instead of being just stuck with a white screen, I want to see a nice spinner showing here that we're actually doing server communication. So I have a React side prepared. If I look inside the offers, the list component is a bit smarter than what it looks. Now, the list component receives another prop, which is pending. If we pass it true, instead of displaying a list of items, the list is going to display a spinner. So let's try that. I'm going to pass it pending equals true. And let's see what happens. And as you can see, the spinner obviously is going to be stuck here forever because the pending is always true. Now, how would we know when to display the spinner and when to hide it? We need to know if there is any server communication going on. Now, if we're living in the, let's say, the old world where we have a regular action creator, what we might want to do is maybe do something like this. And total requests, increase it by 1, and once we're done, decrease it. So this will give us a global counter. Let's put it in a window. It tells us if there are any pending requests to the server. Now, obviously, this code is not something we're going to ever do in React, and especially in Redux, so it might make more sense is to store this variable inside of state. Right? So we can do it by doing dispatch and send some kind of, maybe, I don't know, start network action creator. And once we're done, dispatch and network. Right? Now, the problem here again, we have to duplicate this code for every action creator we have, and or create a special wrapper functionality. What we're going to do in case of the React middleware is something much simpler. Since we know that all access to the server pass through this middleware, we can do the code here. Right? Before we do a fetch, we'll just dispatch start server. And after we successfully fetch the data, or in case of an error, we're going to call dispatch and server. So let's see if we already have those action creators here. We don't, so let's create an export const start server. The term, the type is going to be actions start network. So not start server, start network. And we do exactly the same for export const and network. A very simple action creator. Actions and network. So let's go to the middleware, change this to end network, and to start network. All the imports, import the function, and import this function. Okay, let's give it a try. Now when I hit reload, you can see start network being dispatched, and then end network is getting dispatched. Again, for every API, we'll see the same. Now we just need someone to cache these events and somehow mark them in the state. So if you remember at the beginning, we looked at the state, get state, and we've seen there are 3 different keys here. So offers and books make sense. That's the database we're holding. But there's also something called UI. So the data inside the UI is not really data we're fetching from the server. It's more generic stuff we can put here that can be used by the UI itself. And this is a perfect place to put the counter for the number of requests that are being done. So I'm going to go to the reducer for UI, and let's add it here. So requests, in the beginning it's 0, and what you might notice here, it's a bit weird, I'm using the Redux actions library to make my reducers a bit nicer and cleaner. And then we use that, actions, start network. What we do is start the network, we get the action. I don't need that now. And UI, update requests, UI requests +1. And we do exactly the same for end network. And network, only we're going to decrease the number of requests. Right? Let's see what happens now. Reload, boom. And we had a big explosion. Update, sorry, the current value. I need to use set instead of date set. Set. And the reason you see set and update here is because we're using an immutable library, seamless immutable, which makes our reducer even a bit more cleaner. Instead of having object apply and various separations. All right. So we play around with these functions, and let's take a look at store, get state, UI. And we can see the request is 0, but that's because all the actions are done. But let's connect this one to the spinner and see if it really changes in real time. So I'm going back to my offers, and instead of having the pending set to true, I'm going to pass it to the offers, pending, and take it from the state. State requests. So if there are more requests than 0, that means something is pending. Let's try this now. No items. I click reload, and nothing happened because it's in state UI requests. We got the spinner, and the spinner is off. And let's do exactly the same for the books. Pending state UI request. No. Pending. 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 Right. So hopefully, pending state UI requests. We have everything working now. Perfect. So we have the spinners working, but there is something problematic here. As you notice, I'm trying to reload the offers, but for some reason I'm getting the spinner on the books as well, which kind of makes sense because we have one simple request counter. What would be much nicer if we had a different spinner for each part here, right? So how can we divide it? Well, we can try, instead of thinking about the requests as a single objects, we can hold it as an object containing different requests. So we might have book requests, which is 0. We might have authors requests, which is 0, etc. Of course, I don't want to enumerate them here inside the reducer, so we can do something a bit more generic. And for that, what we're going to do is change our actions. So our start network will not only get the type itself, but it only gets the label to 1 cent. So we're going to label all our network events. By default, let's call it global, and pass it as a payload label. So now reducer knows what kind of network event has been started. I'm going to improve the code here a bit, and for that I'm going to use update in. If you're wondering about the syntax, I strongly encourage you to read about seamless immutable. Payload. And current. Okay. And we do the same for, we'll do exactly the same for the network, for the end network, only decrease it by 1. So what happens when we run the code now? Now we call reload, we look at the start network action. As you can see, the payload is still global, but what we want to do is have a payload be signifying that it's for offers or for books. So let's go inside there and think how we can do that. So if you think about it, the API middleware, how would it know that we want to start offers, books, or any other type of network event? Well, the only thing the API middleware knows is stuff we pass it through the action. So if our original action creator had some kind of a label here, we could just pass it on both to start label, start network, and end network. Let's go back to our action creators, and we can do just that. I'm going to go here to my fetch offers and just give it a label. The label is going to be offers. I'm going to go to my books and do exactly the same. The label is going to be books. Now, when I click one of these, you can see the start network has a payload offered inside of it, and our store has number of offers set to 0, of course, because the request is already done. So let's improve our React. Instead of looking at state UI requests, we're going to be looking at state UI request offers, and for books, at state UI requests books. Right? So we have one spinner here, we have another here, as you can see, both of them are not connected and spread around. So there's another question here. Why are we not using a Boolean for the spinner? And I'm not sure of the meaning of the question, so we are using a Boolean here. If the question is why I'm not using Boolean here, it's because I might have multiple requests at a time. So imagine we have 2 start networks one after another, and then stop 2 end networks. If we're using a Boolean, we would turn it on after the first start network, and the first end network will put it off while there's still something in progress. So we have to have a counter to count how many pending requests we have. Another thing that you've noticed, I've made a few spelling mistakes when I was writing this thing. And that makes sense because I was changing the UI all the time, changing the internal structure, which makes my components a bit dirty, right? Because I have to remember exactly how a state is made. And if tomorrow, for some reason, I want to change the way my reducer organizes the state, I have to change it in multiple places in React. So one way around this is just to go to my reducer and say, you know what, I'm going to add a special getter here. Export const get requests. It receives the state and the label of the request I want. And to just go to the state UI requests, get the label, or return 0 if nothing is set. Now this way, I'm going to jump back to my offers and replace all of this with simple method call to state offers. Import this. This makes the code a lot much easier, a lot nicer and much easier to port. Because if tomorrow we go inside our UI and for some reason decide to change it from request to, I don't know, any other word, all the updates that have to be done are only inside this file. Nothing outside really cares about the internal structure. Let's see if I didn't break anything in the process. Okay, looks fine. So I have a few more questions. Can you explain the const middleware next syntax? That's a hard one. So the reason that's a hard one, and this is the context I'm talking about, why is it done this way? Well, the idea is using composition. And it's done this way so we can support the next action. So we can easily decide where inside our middleware we pass control to the next one in line. If you want to know how it works, you can just take a look at the Redux code itself. It's a bit complicated to understand, but it's really short. It's about, I think the code around this composition is about 5 lines. It will take you a few minutes to figure it out, but once you do, you'll see it's quite magical and pretty. But that is the reason why Redux is built with 3 functions instead of just log middleware, and that's it. So there's a question about the whole idea of RxJS and how it can make the flow much cleaner. Well, RxJS can help in a lot of places. It's kind of a pattern that I'm not sure we can use RxJS well with Redux itself. It's a good question how we can integrate both of them, because the flow in Redux is pretty well defined. So when I look inside my log, it's really easy to understand what's happening. Like everything is a well-defined action. I think you can theoretically use the observable hidden inside the Redux state to observe events and then to act accordingly. I think there's quite a few libraries trying to do exactly that. I don't really have any special thoughts of it. I've never tried to build a large project with that. I can tell you that regular flow Redux, using it this way with the actions, scales up really well for really big projects. Because even when we have multiple people working for a very long time on one project, it's still relatively easy to understand what's happening. Because any event you do causes an action, and you can trace who touches that action. It might be a middleware, it might be a reducer, but everything is a very short and closed loop. Using RxJS in this case still might be nice. Again, not something I've tried on a really big project, so that's why I can't really comment on that. And let's see, what other questions do we have? What is so since middlewares can be composed, what is the guidance on the limits of a number of middlewares in terms of performance? And I don't think you will ever hit any problem with composition of middlewares, because if you think about it, we're not really doing high-frequency trading with the actions on the front end. The number of actions being sent is probably, in the extreme, a few actions a second, because mostly it's interactions created by the user, and there is this limit on the speed at which the user can click things or move things. And if it's server events, again, you're probably not getting hundreds of server events a second. And if you are, of course, there are special ways to handle that. So if you have multiple server events, or you want to listen to the scroll event, then you have to do quite a few optimizations, both in the reducers, by whitelisting or blacklisting events. In the middleware parts, I don't really think you have a problem. So you might have a small problem with the depth of your stack. But then again, the number of middlewares, I don't think I've ever seen a project where the number of middlewares is beyond maybe 10. So if you plan to have 1,000 of them, you might have an effect of performance. But in real-world cases, I don't think there is any worry about composition of multiple middlewares. How do I avoid passing down the same action handlers and portions of the state to nested down children components? That's very simple. You just connect the children. So if you're building something super generic, you don't really have any other options. So if you're trying to build a very generic library that you pass it some kind of data and it passes the data onwards and onwards and onwards, you're kind of stepping outside of the Redux world and trying to use regular React. And regular React doesn't really scale with deep props passing and state work, at least from what I've seen. So in those cases, what you might want to do is pass some kind of information that the next component or its child is going to use to create connect and then collect all the data it needs. So you pass only minimal data. For example, what I mean is, let's say if I wanted to have here a special, let's say, offer image, what I would say is maybe pass the ID of the offer here. And the offer image might contain a connected image component or whatever that using the ID fetches the data. But I want to try to pass a long list of props here to the offer image so it has all the information it needs. So again, we're using the fact that connect is fast and to just connect internal components. I hope that answers the question. Why did I make, let's say, this application seems overly simplistic for Redux. Do you have an example for when you could use this implementation for something more complex? I can tell you that the API middleware, obviously this one is a very simple one, but if you increase it in size about 2 or 3 times, that's the API middleware we use for our projects. That's about the size. And the general concepts of what we've done in these applications is what is being used on projects with multiple man years of work inside of them. So it doesn't really get more complex. And I want to say it doesn't get more deeper or have more levels. It's, again, middlewares, action creators, and reducers, but it just gets more broad. So you have more things inside of your state, more reducers, more action creators, but hopefully not a lot more on the height of the stack. So it's still a few middlewares, and that's it. I think the most important thing when you think about bigger projects is not really the middlewares of a generic code, but rather a correct structure of your state, how you divide it between different responsibilities, how you divide your React code, so the components between different responsibilities, different teams, and bring it all back together. And maybe we'll have an hour talk sometime about the states. So about the code, all the code here is going to be shared. And the last slide, I'll show you a link to the code. Everything is already up in GitHub, so you can access it whatever you want. And I'll show the code in a moment. When do you recommend on using page Redux Persist to store the state on page refresh? So that's a tough question because it really depends on your product. There's a few libraries supporting local store persistence, and you use them when it makes sense for your product. Usually they are done pretty well, so they don't actively update the local storage all the time. There's some kind of throttling built in to make sure you don't do a lot of serialization. And again, it depends on the product side. So if you need to save the data when the user refreshes, or you prefer just to refetch everything, and obviously refetching is much easier to implement, but adding a simple Redux persist will not affect the way we build the stack here in any way. And how would you manage errors on the API middleware that need user intervention? So that's a good question. We have to think about what's the meaning of user intervention. For example, if an error is, and I hope I get the meaning correctly, so if the idea is I'm trying to access a resource I have no access to, so I need to re-log in, and that is pretty easy. So I can have my API middleware do something like this. Fetch error, and again, this is a pseudocode, not real code. If error status equals 403, if I remember correctly, or 401, I forgot the exact name. Then I might do something like this: dispatch logout action creator, and maybe even something like this: dispatch redirect login. And so I can do some generic handling for specific error types. For other error types, I might just show a message. And if it requires some kind of user interaction, I have only two ways, like two normal ways to access. One is to change something in the state, which causes a change to the UI. Open a pop-up, I don't know, prevent a form from being saved and show the errors, because the errors are now inside the state. Another one is just redirect the user to another page where he can do some work to fix the problems. I don't think there are any other ways to handle errors gracefully. It's either updating the states of the UI updates or redirecting to another place. Again, you will probably find that in most cases, except for form submission and errors like access denied, most errors, there's not much you can handle. You just show the user that you had a problem and maybe roll back some changes, again, with an action, but there's not much you can do. So usually the API middleware is generic enough to handle most error scenarios. And the last question we have is, are middleware operations synchronous? And yes, so middlewares are completely synchronous, the same as the whole Redux store is synchronous. So from the moment you call dispatch, everything is run in synchronous fashion until the dispatch returns back. So the only thing that's not synchronous is places like this. So this thing, of course, it posts a promise that when it's resolved, another action is dispatched. But the original flow, all the middlewares up to the reducer and back, it's completely synchronous. There's no parallelism in Redux. All right, so already about 10 minutes over time. I really hope you guys learned something new from this presentation. All the code is available here, github.com/500tech, middleware lecture. I'm going to leave this slide up and also add it to the comments of the YouTube. I really hope you enjoyed it. If you have any questions, feel free to go to our site and post a question there, or send it directly to me, to boris@500tech.com. If you have any ideas for other things you want to learn about Redux or more advanced stuff, again, please send us a message, and we hope to do more webinars in the future. Thank you very much, and have a good day. Goodbye.